Hi, looking at the integrated space weather analysis, and these are two composites of the sun, and then down on the lower western side, the right bottom here, there was something interesting. But I thought this one on the left bottom was more interesting. So you'll see this blast come up right there, boom. And it goes up into space, doesn't come back to the sun, but it goes to some object out there. So I zoomed in here. That looks a little bit of a circle. A circular edge there, little circular there. So whenever you see circles, there's that blast. Look at that blast. And it goes out into here. It doesn't go back to the sun. It goes to some object out here. So that's one of the stellar cores absorbing energy off the sun and weakening the sun. As Dr. Sylvia Albers says on Planet X Physicist, she's the one you want to listen to. Then here's solar winds, sun's from the right. Shows a lot of energy coming in from somewhere on the back side of the Earth. Night side, day side of the Earth. So the energy is coming from somewhere and not the sun. So until they remove this information, that looks pretty suspicious to me. And then this shows the ecliptic plane, the Earth's yellow one, and it's just interesting to see positions of the planets, satellites, and energy coming off the sun. This one on the right's pretty good. If any big thing, energy comes by, you can see it here better than the one on the left, I think. Anyway, that's interesting. Now this one shows coronal holes. It's at 211 angstroms, which is the best to see coronal holes. Now this, see, it starts, I tried to get this for a month, but it let me see it for a week. So here's the coronal holes it says are there. And why those spots are so much darker than, I don't know, right here, I don't know. But it looks like the whole sun's turning into a coronal hole to me. So this one, they let me go back a week. And then when you're on the Helio viewer, just clicking around, you want to look for things that are pixelized. And if they're pixelized, well, that's interesting. The XYZ circuit must have went on the blink again at NASA. But let's look at it anyway. Let's make a movie. So you go up here and you can click this to make movies. Then you pick the time. I wanted to see the whole month on this one because I was like, wow, okay. Okay. Can't see it. No images found. Well, that's quite the problem. So then I went all through all these, and none of them work. They all say this. So NASA's hard at work again, covering stuff up, I guess. Just another government organization keeping you happy. And anyway, I went to the E.P.A., looked around for UVA, UVB, UVC information. So the most modern article I could find was 2010 from our E.P.A. that really doesn't do anything anymore. And so UVC is an interesting one. 100 to 290 nanometers completely absorbed by the ozone layer and atmosphere. Well, that's a relief, because wow, you can just take it easy, because that's not going to ever get down to the Earth's surface. Because see, here's the little chart. UVC doesn't make it. So there you go. That's all you need to know. If the EPA says that, it's true. Except I have a meter that measures from 220 to 275 nanometers, and whenever I go outside in the daylight, I can measure UVC. UVC is next to X-ray. So I would stay out of the sun as much as you can. We'll see if they ever tell us the truth. I mean, you can measure it with an instrument. Okay.